Hello everybody, this is the notes for section 7.2, Advanced Geometry. In the first section we talked about Pythagorean Theorem. It stated that if you have a right triangle, then the leg squared plus the other leg squared will equal the hypotenuse squared. The converse of the Pythagorean Theorem is what we're talking about in this section. Remember the converse statement, you just flip the hypothesis and conclusion. So, the converse of the Pythagorean Theorem states that if a leg squared plus the other leg squared equals a hypotenuse squared, or that third side squared, then it has to be a right triangle. All right? So we're just using the equation from the Pythagorean theorem to say if this equation works, then you have a right triangle. So it's kind of like a check. Yes, this thing is a right triangle. All right? You don't really need to write down this whole thing here, but this is the main idea along with the picture. Okay. So, I want to take a look at a Geogebra sketch to get this idea. Right here. All right. So I have this triangle drawn in here. It's a right triangle. You can see that at angle B, it's a 90-degree angle. I have the measure of the hypotenuse squared to equal 80. And this sum equal to 80, that's the sum of the squares of the two legs. So, because the sum of the two legs equals 80 degrees, and the hypotenuse squared equals, no, sorry, I said degrees, didn't I? Not degrees. The sum of the two legs squared is 80. This hypotenuse squared is 80. Because those things are equal, we have a right triangle. So now, what if I took point C and moved it? That angle at vertex B is now an obtuse angle. It's more than 90 degrees, less than 180. So what happened is that hypotenuse, or that third side, AC, that got longer. Okay, so now if you look at these numbers, the hypotenuse squared is now 89. The sum of the other two sides squared is 81. That third side, AC, it got longer, which is what opened up that angle at vertex B to make it a 97 degree compared to a 90 degree. So that third side squared, the hypotenuse squared, it got bigger. Okay, so when we compare these two numbers, the sum of the two sides squared is less than that third side squared. Okay, if we go the other direction, let's move it back up. Now we're back to 90 degrees. Notice those two numbers are equal. If I move point C here, now our angle at vertex B is less than 90, so now it's an acute angle. But look at that third side compared to right angle, acute angle. That third side, AC, it got shorter. Now, when we compare that formula, the sum of the two sides squared is 66. That third side, what was the hypotenuse when you square it, it's now less than the 66. Okay, this is what's happening with this converse theorem. When these numbers are equal, sum of the two sides squared equals the third side squared, you got a right triangle. If that third side, the longer side squared, is less than the sum of the other two sides squared, you've got an acute angle, which means you've got an acute triangle. If that third side squared is more than the sum of the other two sides squared, like we have here, you've got an angle that is bigger than 90, which is an obtuse. So that leads us to these two theorems. You don't have to copy all of this down, but again, just like in the last one, this is the main idea along with the picture, and same thing here. So take a second, along with the picture, take a second, copy these things down. Okay, so what we're looking at is you have a triangle, you have three sides of the triangle. You want to know, is this triangle a right triangle, an acute triangle, or an obtuse triangle? So if a squared plus b squared equals c squared, and c being the longest side, if that's equal, you've got a right triangle. If that third side, the longest side squared, is less than the sum of the other two sides, squared, then what you're looking at is an acute triangle. And down at the bottom, if that longest side squared is more than the sum of the other two sides squared, you're looking at an obtuse triangle. Okay? So we have these three equations that are going to tell us I'm dealing with a right triangle, dealing with an acute triangle, or an obtuse triangle. All right, that's the gist of the notes. The next video is using this stuff, the examples. Please watch.